Good morning, chemistry students. My name is Mr. Adam. This is chemistry. Today is the 7th of April. It is a Tuesday, and it is a day 4. So, welcome back to day 7 of online learning. We're moving right along, chugging along with this online learning process. In today's video, I've been mostly focusing on checking in with you guys, seeing how you're doing. I still want to do that, obviously. But today's video is going to be a little bit more involved because our topic for today, our lesson for today, Lewis dot symbols, takes a little bit more practice and it's a little bit more of a new skill. So if you haven't been watching these videos entirely all the way through, that's okay. Completely get it. But this one might help you out today with the assignment that you're going to have to do in learning how to create these Lewis dot symbols. So we're going to get the whiteboard, we're going to break out the periodic table again, and we're going to work through these Lewis dot symbol things in a second here. But before I do that, this is your daily reminder to do exactly what I told you to do on day 1 of online learning. Now, I probably told you a couple things that I wanted you to do, but the one key thing was I said, please do not overstress about this stuff. This is a new process to all of us, right? And it's not easy. It's kind of difficult to get used to it and get acclimated to it all. It's easy to worry about this, saying, I'm not exactly getting this stuff when I'm just learning it online. I'm not exactly understanding everything. I'm really stressed that I'm not going to pass. This is your daily reminder. Don't overstress. This school and me and all your other teachers, our goal is to not let you fail. It's not to not pass you. It's not to make this stuff so difficult that you can't understand it. We're trying to give you the best education you can while also alleviating your stress and saying, hey, you're going to pass. It's going to be okay. So keep up your effort. Keep working. Keep completing these things. If you don't do the work, yeah, that's going to hurt your chances of not passing. But if you do the work and it's not perfect, if you didn't learn everything perfectly, well, guess what? I wasn't able to teach you perfectly. So don't overstress and don't feel like you're not going to pass or like you'll fail this stuff. Please don't overstress. Not too much in the way of announcements today, like I said. So let's take a second, breathe, and get right into the lesson. Hi, kitty cat. My cat is here visiting during our daily lessons. Here, come here. Second daily announcement. Here's my kitty cat. She says hello. All right, so we have my cat, we have some chemistry, we have some periodic tables, and let's get to our lesson today. Thank you, kitty. Oh, now she's on my lap. All right, so today, our most important tool today is our old friend, and that is the periodic table. So to make sure that you're prepared for today, either have your blue periodic table handy that you had in your binder, or you can navigate to this link that I put in the Google Classroom, okay? That link links you to a dynamic periodic table, it says, and that link is to www.ptable.com, okay? So that is to this really cool, super handy, interactive periodic table. You can actually learn a ton from that periodic table by exploring it, by looking at the Wikipedia links and whatnot. But make sure to go to that site if you don't have a periodic table handy for you. All right, Katie, you're cute, but we gotta learn chemistry. All right, so we have to bring back an old skill today. So we have to look at our periodic tables and be able to determine this thing called the number of valence electrons. We got to be able to count valence electrons. Now, this is a skill we haven't talked about in a long time. And we haven't talked about electrons even in a long time. But remember, electrons are these tiny negatively charged particles that kind of zoom around the outside of an atom. And as they do that, they're moving and they're always trying to bond and pair up and form the perfect number. Okay? So 99% of chemistry is determined by these electrons. How they move, how they're shared, and how they're connected to other atoms, that's going to determine what chemistry is like, what happens with different atoms and molecules, how they bond, and how they form compounds. So valence electrons, if you don't remember, are the electrons on the outside of atoms. We said that there are different shells, and there are shells closer to the middle and shells on the outside, right? And the shells on the outside are very important to us because they're the only shells and the only electrons that are going to be involved in bonding, which you should know from yesterday is a huge part about what we're talking about in this unit, right? We're talking about bonds, how molecules form, how atoms connect to each other. The valence electrons are incredibly important for that, okay? So valence electrons, the way you find valence electrons is really easy. You're going to look for your element on the periodic table. So we're going to start with fluorine, F, right? So we're going to look at our periodic table today, and we're going to find fluorine, F. I'll let you take a second to find it on this periodic table here. Okay, it's right over here, right? So we're going to find fluorine F. And we can see that it is atomic number 9. It's got a bunch of information. It's got a couple different languages to pronounce it. It's got the electron configuration on here. It's got the atomic mass. But all that, the actual cell that fluorine is in, does not matter to us for valence electrons. All that we're actually looking at is right above it, the column or group number that it's in, right? So remember, when you're looking for valence electrons, look at the column number. Okay, so that number says VII. If you know your Roman numerals, you should know that V is 5 and each I is 1. So V, 5 plus 1 plus 1 would be 7. Okay, so what that says is fluorine is in column number 7. So how many valence electrons is it going to have? 7. Right? If something is in column number 5, it's going to have 5 valence electrons. If it's column number 1, it's going to have 1 valence electron. It's that easy. Look at your element on the periodic table, find its column, that tells you the number of valence electrons. So remember, if you're confused, that no element can have more than 8 valence electrons, right? 8 is our perfect whole happy number, and everything's trying to get to 8. We're going to learn about that in what we call the octet rule in lesson 2.6. So remember, it can't have more than 8 electrons. So if you have a different periodic table, the one on ptable.com or this one that I'm going to show you back here real quick, if you have a different periodic table, and I'm just going to move up here and then find fluorine, if you have a different periodic table, it might show you that the column numbers are something like 13 and 14 and 15 and 16 and 17, right? So again, don't worry about that. You would still find fluorine here and see that it's in column number 17. And if it's 17, if it's over 8, remember you can't go over 8. So all you want to do is take the last digit of that and figure out the number of valence electrons. So for column 17, if you take the last digit of 17, it's just 7, right? So if you're looking on ptable.com today, and it's telling you that you're in column number 17, you don't care. It's not 17 valence electrons. You can't have more than 8, and you know that. So instead, what you want to do is take that 17, look at the last digit, and know that, okay, 17, column 17, that's actually just going to have 7 valence electrons. All right, so if we look at nitrogen, check out nitrogen on ptable.com. Go ahead and look that up. You'll see that it's in column 15, right? Group 15. So, how many valence electrons should it have? It should have 5, right? It should have 5 because the last digit of that is 5. All right, now for the new stuff today, right? So today we're drawing these cool things called Lewis dot symbols. Not only are they fun to draw, and really they are kind of fun, but they tell us a lot about how atoms are going to bond and how they're going to connect to each other, right? So when you do the assignment for tomorrow, I encourage all of you to have a piece of paper or a notebook so you can actually draw these Lewis dot symbols out, right? It's a very important skill because it tells us just why everything works and why everything bonds the way it does. Okay, so Miss Marnick's video tomorrow should help you out with it a lot, but I would be really sad if I didn't get to actually teach this to you too. So let's take fluorine, which was our example. And we said fluorine had 7 valence electrons. So I'm going to write fluorine, the symbol for it, F, and 7 VE, valence electrons, right? Okay, so when you draw Lewis dot symbols, you want to look at your symbol, F, right? And on this fluorine, you want to imagine that it has 4 sides, right? It's got north, east, south, and west, okay? And when you draw out the symbols, you're going to put electrons in the north, east, south, and west. You're going to go around clockwise and put 1 electron at a time until you run out. And remember, you can't go over 8, and you want to use the number of valence electrons that you have. So I'm going to try to draw this as best I can. So I'm going to take fluorine. I'm going to draw 1 electron in the north, right? Okay. I'm going to draw my second electron in the east, third electron in the south, fourth electron in the west. Now, I have 1 electron on each side, but that's okay. I can actually have at least 2 electrons on each side. Okay, I'm going to draw another one in the north, another one in the east, another one in the south. And now, if you've been counting, you'd realize that's 7 valence electrons, right? So this is 7 valence electrons. This is how many valence electrons fluorine has. And so this is the correct Lewis dot symbol for fluorine. Now, this is really, really important. You're going to notice now that for some sides, you have pairs of electron, right? You have 2 electrons that are paired up. Those are what we call lone pairs. And they're happy. They already have a partner. They're already paired up. They don't want any other partners. So lone pairs are going to stay exactly as they are. But you'll see over here that there's one electron that's all by itself. That electron's not happy. It doesn't have a partner. So for those electrons, we're going to find out that they form bonds. So if you ever see a lone electron by itself, that electron is going to form one bond. So fluorine, you're going to see, is going to form exactly one bond because it has one electron that's all by itself. Okay? So let's check out nitrogen here, right? So nitrogen, we see that it has 5 valence electrons. So go ahead and do this with me. Take out a piece of paper or something, do it with me, or do it in your head, right? We're going to put the first electron on top in the north. Okay? Our second electron is going to go in the east. Third electron is going to go south. Fourth is going to go west. And the last one is going to go on the north. Okay. So tell me this. How many lone pairs are there on this nitrogen? There's one lone pair. Remember, a lone pair is this pair of electrons that are alone by themselves, okay? And how many bonds is nitrogen probably going to form? Remember, to find how many bonds it's going to form, you want to count how many electrons are by themselves on the side, right? So we have 1, 2, 3 electrons that are by themselves on the side, okay? So that means that nitrogen is generally going to form 3 bonds. Wait a second. What did we learn with honk 1, 2, 3, 4? Let me write this down real quick. What did we learn yesterday with honk 1, 2, 3, 4? How many bonds does nitrogen normally form? Honk 1, 2, 3, 4, right? N normally forms 3 bonds. N, 1, 2, 3 bonds. So that's why Lewis dot symbols are important, because they tell us how exactly all of our atoms and all of our elements are going to bond, right? So that's going to be super important to us. All right, so that's Lewis dot symbols. We'll talk more about Lewis dot structures and how multiple atoms fit together a little bit more tomorrow. So don't worry about that too much for now, but we'll talk more about that tomorrow. Make sure to tune into the video. All right, finally, for your share of the day. This is going on longer, so I want to kind of wrap this up. For your share of the day, I want you to think back again to your whole year so far at high school, right? I want you to think, what has been the best part about being a high schooler, right? Being in high school, being in the biggest school that you have in the district, right? The biggest school amongst all the freshmen and sophomores and juniors and seniors, right? Is it something that you get to do that your parents didn't let you do before? Do you feel different? Do you look different? Or do you have a different image or reputation? Do you like the building? Do you like the teachers? Do you like the classes more than you did in middle school? Really focus on what do you like about the high school? What do you like about being in high school? You might not like a lot of things. You might, for the majority, dislike things, right? But focus on one thing that you really like about being a high schooler this year, okay? I will see you all tomorrow. We'll talk a little bit more about Lewis dot structures. Please keep tuning into these videos because they are going to become more content relevant and maybe help you a little bit more with the content that you need to know. So that's all for now. Have a great day. Good luck today. Get the reading done. Watch the video. And I'll see you all tomorrow. Let's get a 1, 2, 3. Clap on me.